Hello folks, we are starting with the exercise 14.5. Again, every time it's something new that we have to have. So here also we have, they give us a statement and they ask us to find out the proofs by different methods. So that's what we are going to do. The statement that they gave us is that there is a real number x such that x cube plus 4x equal to 0. That real number is x cube plus, has this equation x cube plus 4x equal to 0. If that is the case, you have to show that x equal to 0. That's a question. And there are three methods by which they ask us to do. So gradually we will do by all the three methods. First method is a direct method. So let's write the given and the to prove that. Given is any real number x is given to us which is satisfying the property x cube plus 4x equal to 0. And what do you have to show? We have to show that x equal to 0. So we are taking the proof. How do we go about it? Given that we are given that x cube plus 4x equal to 0. So obviously we can have this x common. So x times x squared plus 4 equal to 0. Now whenever a product is 0, we know that both the factors have to be equated to 0, and then we have to find out the possibilities. So here either x is 0 or you have to consider x squared plus 4 equal to 0. Now x squared plus 4 equal to 0, there are various ways of saying, looking at it, that any real number, if any real number a, if you have, then x squared plus a is irreducible. You cannot reduce it. Okay, you don't have a root. The root is only in complex number. It's not there in real number. So this thing is irreducible. You cannot find a real root. So you can write it is not possible to find a real root for this x. We can try if you want with minus b plus or minus root of b squared minus 4ac by 2a. But technically at this level you should know that any real number which is of the type x squared plus a is irreducible in real numbers. It cannot be reduced. Okay. So that is why it does not have a real number. It doesn't have a root. So therefore we cannot get an x value. So automatically what we are left with is only this option, x equal to 0. So starting with this, we have got this. So we have proved it, whatever that we wanted, hence proved. Okay, then comes a method of contradiction. Nothing new to us. N number of problems in the 10th standard we have done. Let if possible this happens, and then we start, we work, and at some step we come across a contradiction and we say that this contradiction came because our assumption was wrong. So what we have assumed is not correct, and hence this is the value. So sometimes indirect proof means, or what is that method called, contradiction, is whatever that we have to show, we take the contrary to that, and then we land up into a contradiction, and we'll say that this contradiction arose because we had made a wrong assumption, and therefore we have to alter our assumption, make the correct assumption, and that's how we get to the proof. So we'll get across with that once again. Given we are given any x that's a real number and x cube plus 4x equal to 0. We can write a common every time. There's no need to write, but then when you look at the proof, maybe it is easy to refer when you have it there, to prove that x equal to 0. So we'll assume x not equal to 0, and then we will bump into a contradiction. So let's check proof. So it's a very format based thing, you get across with the format. Let if possible, let if possible that x is not 0. Okay, then consider x cube plus 4x, which is x times x squared plus 4. Or rather we could have taken, I think we could have taken like this, because it's given. Consider this to be equal to 0. So which when we work out, it is x times x squared plus 4, which is equal to 0. Here x is 0 or x squared plus 4 is 0. Obviously when we come across something, a product 0, either of them or both can be 0. So we are coming across those possibilities, but x is not 0 by assumption. Therefore x squared plus 4 equal to 0 is the only possibility. And x squared plus 4 equal to 0 cannot yield any real value of x since it is irreducible, you cannot reduce it, or you can do this minus b thing since it is irreducible. Or what we do is, I think it's better that we find out and we say that that contradicts that x is real number. Yeah, I think that is one way of doing it. X squared plus 4 equal to 0. You could have like this. Here. Now, we are trying to solve this. A is 1, B is 0, C is 4. So, therefore, x will become minus b plus or minus root of b squared minus 4ac by 2a. So, that is plus or minus minus 16, root of minus 16 by 2, which is like plus or minus 4i by 2, or rather plus or minus 2i. So, it's not a complex, it's a complex number. This contradicts the fact that x is real, that x belongs to R. So, I will have small thing here. This contradiction arose since our assumption is wrong. Therefore, x equal to 0 is the correct assumption, correct statement. So, that's about the we have borrowed so much place from the contrapositive part. Now, let's see contrapositive. We know we have done series of problems given. Now, in this case, see, contrapositivity is for the statement that is given to you. If p then q, then you have to alter it, and you have to show if negative q then negative p. So, given will be negative of this, given x not equal to 0. And what is to prove? To prove that x cube plus 4x is not equal to 0, and x of course is a real number. So, how do we go across the proof? So, we are given that x is not equal to 0. Let's consider this and let's see what we can work with this. Consider x cube plus 4x. We know that it breaks as x into x squared plus 4. Here, x is not 0, right? And x squared plus 4 is also not 0, since x belongs to R, and x squared plus 4 is irreducible in R. So, therefore, x not 0, x squared plus 4 not 0 will imply that x into x squared plus 4 is also not 0. Product will not be 0. No, if one of them is not 0, how can the product be 0? So, it's not 0. But that is as good as saying that it is x cubed plus 4x is not 0. So, we have started. Therefore, hence proved. This is what they had asked us to prove. Hence proved. So, by contrapositivity, we have shown that the given statement is true. So, these are the three concepts in which three methods by which we have shown the given statement. That was our whole chunk of question number 1. Now, we move to the question number 2. Now, question number 2 is an interesting question. It says that, I have shortened it and written, so I will read the correct thing. For any real number a and b, a squared equal to b squared. A squared equal to b squared implies that a equal to b is not true by counter example. This is not true, that if at all a squared equal to b squared, then a or should be equal to b. Doesn't happen. It happens in most of the cases, but there are cases where this doesn't happen. So, the question says that because it's not a true statement, it's you give a counter example and you show where it doesn't happen. So, pretty easy. Again, just if you think certain thing, you will get n number of examples. So, we will cite one example where such a thing happens, right? So, for example, let a be 3, why 3? 1 is there, and b is minus 1. Okay. So, what is a squared? It is 1. And what is b squared? That is also 1. Here, a squared equal to b squared, which is 1. But A is not equal to B, but A, which is 1, is not equal to B, which is minus 1. Understood? So starting with, so thus A squared equal to B squared equal to 1 does not imply that A is equal to B, right? So this is a counter example, and this is the meaning of counter example. You give an example where it doesn't hold true. For a false statement it does work. So that was our part 1 video of the exercise 14.5. In the next part we meet with next set of problems. Thank you.